Hello everyone. Today we are going to discuss atmospheric temperature, which is one of the important meteorological parameters. The content we are going to study is first, what is atmospheric temperature, what are the different layers of the atmosphere and how atmospheric temperature changes in it, what is horizontal distribution and vertical distribution, how we are going to measure atmospheric temperature and certain terminology related to the atmospheric temperature. So without further delay, let's start the topic. Atmospheric temperature, as the name suggests, is the temperature of the atmosphere. The primary source for this is sun. The portion of the solar radiations received by the earth is called as insolation, and at this point the solar radiation has short wavelength. It warms the earth's surface. The earth in turn radiates the absorbed heat back into the atmosphere in the form of long wave radiation. This is known as terrestrial radiation. Most of the atmospheric gases, especially carbon dioxide and water vapor, that are almost transparent to the short wavelength are able to absorb only about 15% of it, but they can absorb around 85% of the terrestrial wavelength. Thus, we can say that the atmosphere gains the temperature largely from the earth and not directly from the sun. This heat then gets transferred around in the air by the process of conduction and convection. The atmosphere is a blanket of air surrounding the earth. It has various layers, but the temperature is not uniform in these layers. For example, the lowermost layer of atmosphere is called as troposphere. It has a thickness of average 13 km. The atmospheric temperature in this layer decreases with increase in height. This is because the air near the ground gets most of the heat than the air above it, and this heat dissipates as we go away from the ground. The layer above troposphere is called as stratosphere. It extends from 6 to 20 kilometers above the Earth's surface to around 50 kilometers. In this layer, the temperature increases with height. This is because of the presence of ozone layer. Ozone layer absorbs large amount of UV rays in the process, releasing a lot of heat. The next atmospheric layer is called as mesosphere. It extends from 50 kilometers to 80 kilometers above the surface of the Earth. Here we find that the temperature once again starts to decrease with increase in height, because there are fewer air molecules to absorb the incoming solar radiation. However, this layer do contain carbon dioxide molecules. These molecules absorb and then re-emit the infrared radiation. This is called as radiative emission. This re-emitted heat escapes directly into the space before being absorbed by other molecules simply because of the presence of fewer air molecules in this layer. This makes mesosphere the coolest layer of the atmosphere. The outermost layer of the atmosphere is thermosphere. Here the temperature increases rapidly well beyond 1000 degrees centigrade because of the high energy radiations like UV and X-ray gets absorbed in this layer. This absorption causes the atom and the molecules to ionize. They gain energy and move faster, increasing their kinetic energy, which is again directly related to their temperature. In the end, we can say that as we move from troposphere to thermosphere, the atmospheric temperature first decreases, then increases, then decreases, and then again increases. Till now, we have seen that the atmospheric temperature keeps changing in its various layers. We are going to focus mainly on the lowermost layer, that is troposphere, because this is a layer where we live, and also because most of the weather phenomena takes place in this layer only. The average temperature of troposphere at sea level is 15 degrees Celsius. We are saying average temperature because even in troposphere, the temperature is not uniform but varies. We can study this variation as horizontal distribution and vertical distribution. The horizontal distribution of temperature refers to how temperature changes over the Earth's surface across the latitude. So the first important factor itself is latitude. Temperature changes with latitude due to the oblate spheroid shape of the Earth. Due to this particular shape, sun rays strike the Earth at different angles. At low latitude, like near the Earth equator, the angle of incidence is maximum, that is 90 degree. This means that the solar radiations are getting concentrated over a small area, making it a hotter place. That's why some of the hottest areas are found near the equator. Contrary to this, at higher latitude around pole, the solar radiation strikes the earth at low angle. This means that most of the heat is lost as they travel a long distance in the atmosphere before hitting the earth's surface. Hence, these areas are cold. Thus, we observe that latitudes have an inverse relationship with the temperature. That is, low latitude have higher temperature and high latitude has low atmospheric temperature. The next factor affecting the air temperature is land and water distribution. We have seen that the temperature is dependent on latitude. However, this doesn't imply that all the places lying on the same latitude has the same temperature. The irregular distribution of land and water on the Earth's surface has a great impact on the temperature. Land areas warm and cool rapidly compared to the water masses. This implies that the temperature of the air is more above the land than above the ocean. This difference in air temperature causes sea breeze and land breeze in the coastal areas. In the same way, there are seasonal contrasts in the temperature causing local wind pattern on the earth. The next factor is ocean current. Ocean currents can be called as giant rivers of water found in the ocean. They are caused by the flow of wind, Earth's rotation, salinity, and temperature. Now, ocean currents significantly influence the global temperature. Warm ocean currents originating from the equator raises the temperature of areas they flow through, while the cold ocean currents originate from the poles lower the temperature of the coastal areas. The ocean counteracts the uneven distribution of solar radiation reaching the Earth's surface and thus help in stabilizing the climate. This can be achieved as water has a high specific heat capacity. This means that to raise the temperature by even 1 degree centigrade, a lot of heat is required. Additionally, much of the solar energy goes into evaporating the water and thus is not available for heating the water. The fluid character of the water permits the heat to be dispersed to a greater depth and over a larger area. All these factors renders water to heat very slowly. The next factor is greenhouse effect. We all know that our Earth is surrounded by atmosphere which contains various gases including greenhouse gases. What are these greenhouse gases? Now, these are the gases which have a tendency to absorb the sun radiation. They prevent the heat from escaping into the space and hence they increase the Earth's temperature and make life possible on the otherwise freezing Earth. Example of these greenhouse gases are water vapor, carbon dioxide, ozone, methane, nitrous oxide and chlorofluorocarbon. However, increase in the concentration of these greenhouse gases traps more and more heat, leading to the warming of Earth's surface and lower atmosphere. This in turn causes climate change such as rising sea level, extreme weather events and disruption to the ecosystem. The last factor in the horizontal distribution is vegetation cover. Plants absorb a lot of solar radiation to perform photosynthesis. They block direct sunlight to reach the ground and thus prevent heating of the ground as well as heating of the air above it. Hence, the temperature under a tree is significantly low during the daytime. Also, trees release water vapor through the process of transpiration, and as this water evaporates, it absorbs heat from the surrounding area, further cooling and thus reducing the temperature. After horizontal distribution, let's move on to the vertical distribution of atmospheric temperature. In the troposphere, the atmospheric temperature gradually decreases with the increase in the altitude. It means the air is warmer near the surface of the Earth than the air above it. This vertical gradient in temperature is standard and hence called as normal lapse rate. When calculated, it is found to be 6.5 degrees Celsius per 1000 meter. Normal lapse rate is very important to meteorologists in forecasting the cloud formation, the incidences of thunderstorm and the intensity of the atmospheric turbulence. Sometimes, instead of decreasing, the atmospheric temperature increases with increasing altitude. It means the air is colder near the Earth's surface than the air above this. This is called as temperature inversion or negative lapse rate. This can have severe adverse effect on weather. For example, a negative lapse rate makes the atmosphere more stable by inhibiting the vertical mixing of air. So, it can trap more pollutant and moisture, leading to the increased fog and smoke-like condition in the area. Next, we will see how to measure the atmospheric temperature. So, the instrument used to measure atmospheric temperature is called as thermometer. The various units used are Celsius, also called as centigrade, Fahrenheit and Kelvin. Kelvin is the SI unit. The formula used to interconvert these units are, first between the Kelvin and Celsius it is Kelvin is equal to Celsius plus 273.15, and between the Celsius and Fahrenheit it is equal to Fahrenheit is equal to 9 by 5 into Celsius plus 32. Moving to the last section, let's study some of the terminology related to the atmospheric temperature. First is albedo. Albedo is a measure of amount of sunlight reflected off any surface. Surface with high albedo reflect a large portion of incoming solar radiation, while low albedo means absorbing more energy. From the diagram it is clear that water and vegetation has low albedo, meaning they reflect less, or in other words, they absorb most of the sunlight. On the other hand, fresh snow, white clouds, they have high albedo, meaning they have high reflectivity and that they absorb very little solar radiation. This difference in reflectivity significantly impacts the surface temperature and weather pattern. The next term is isotherm. Isotherms are lines on the map that connects points of equal temperature at a certain time or over a certain period of time. If the isotherms are very close to each other on the map, it means that the temperature changes very rapidly over the distance. On the other hand, if the isotherms are widely spaced, it means that the temperature remains more or less same over a certain period of time. Let's quickly go through all the things we had seen in this topic. First is insolation and then terrestrial radiation. Then we had seen how atmospheric temperature changes in the various layers, like in the troposphere it will decrease, then in the stratosphere it will increase, then mesosphere again it will decrease, and then in the thermosphere it will increase. Then we had seen how in the troposphere, in the lowermost layer, the temperature is not uniform and it is changing. So we had seen the horizontal distribution and the vertical distribution in the troposphere. Then we had seen that the atmospheric temperature is measured using the instrument called as thermometer, and the various units are Celsius, Fahrenheit and Kelvin. We had also seen how they can be changed from one unit to other. And last we had seen the terminology like albedo and isotherms. This was all about atmospheric temperature. If you have any doubt, please put it in the comment section. Thanks for watching.